My name is Kelsey Kettlehet, and I am an engineering associate with the Program Development Department at AIChE. And today I am sitting with Joseph DeSimone, who is the CEO and co-founder of Carbon. And he is also the faculty member at University of North Carolina at Chapel Hill and also at North Carolina State University. Joseph was also on, he was one of the featured speakers at the 3D printing session today. So Joseph, welcome.
Thank you.
I guess to start off, I wanted to ask you a little bit about what sorts of impacts we're seeing on manufacturing and other industries, and also kind of what opportunities have arisen because of the technologies in 3D printing.
Well, today 3D printing is principally about prototyping. You know, in essence, nobody's doing 3D manufacturing. Everyone's talking about it. The industry is only a $5 billion industry today. That includes machines and chemistries, services, parts made. Put that in context, the U.S. polymer industry is a $400 billion industry. And principally the reason is I think 3D printing has hit a technological ceiling, so to speak. In the Jeffrey Moore's vernacular of crossing the chasm, 3D printing has fallen into the chasm. And what I mean by that is it's been really effective for the techies, people that want to prototype something and are happy to cobble together other equipment and be in the lab, and it's almost like a science experiment. But the economic buyers, those that are in manufacturing, who really don't care about technology, they want something game-changing, cost-effective, those economic buyers have not seen 3D printing at all. And that's because of the technological shortcomings of the current technology. And so Carbon, we're changing that. You know, we published a paper in Science about 18 months ago and gave a TED Talk to talk about a new technology. And now we are commercializing that and really focused on iterating parts, designing parts for actually production. And we have some really amazing partnerships focused on trying to cross the chasm into true manufacturing.
So you just mentioned that you have a new technology, and I think it's called continuous liquid interface production, or CLIP is what you call it, right? So can you tell us a little bit about CLIP and what it means for 3D printing?
Yeah, CLIP is a new approach. You know, we use light to set the shape of a part. And light triggers photopolymerizations. Everyone knows about that. But what we do differently is we also use oxygen. Oxygen inhibits the photochemistry. And so what we do is we have a configuration where we have a reservoir of liquid resin. We lower a platform into the liquid resin. At the bottom of the reservoir is a very special window. And this window is not only transparent to light, and we have a UV DLP projection system underneath, but that window is also highly permeable to oxygen. And so from a chemistry point of view, as we photolyze the resin, we consume the oxygen. There's an oxygen gradient depletion in the resin, and that becomes a driving force, chemical potential driving force for driving oxygen from under the window into the resin. And so what it does, it creates a liquid interface. We call it the dead zone. And having a liquid interface allows us, when we lower the platform into the reservoir, by combining light and oxygen, if we just had light, we'd glue the platform onto the window. And then you're stuck. But if you have oxygen coming through the window as well, it inhibits the adhesion of the part onto the window. And so we maintain a liquid interface. It's only about 35 microns. And so as we pull the part up, and we do a choreography basically between the Z-axis pulling of the object and the digital light projection system. Pulling the object up, resin flows in underneath the object, replenishes the gap, and then we photolyze that, and so we're able to build parts in continuous manner.
Wow, that's really interesting. So I guess my next question would be then, what are you seeing as the next step in 3D printing, the next advancements that we might be seeing?
So what we did is we bundled the technology into an amazing new product that's internet connected. And so the machines spew over 1 million data points a day back to our servers at Amazon Web Services, and we collect a massive amount of data, and we learn. And we learn how the printer works, and we are putting different arbitrary shapes into the printer, and the printer is getting better and better, and we push software every 5 or 6 weeks to the printers in the field. And so I think of this as software-controlled chemical reactions to create great parts. And with that, we then iterate on designs with our customers to make end-use parts, and then we focus on trying to make them at high speeds. We've printed up to hundreds of millimeters an hour and even beyond, so that we have an economically viable throughput, coupled with amazing materials that have the kind of properties that people want in a final part, right? So if it's automotive, you have a certain flame rating that's different than interior aircraft, where you have fire and smoke ratings associated with that. Then you have medical grade resins, or you have food grade, food processing equipment. Just all these different examples where you not only have a set of mechanical properties, but you're making parts that are validated for an application. And we're working with our customers to build a factory that uses ChIP to have an economically viable product made on the grand scale. And so we have major customers doing that with us.
Wow. So that sounds really interesting. And I wish we could talk even more about this, but we're going to wrap up. So I just wanted to thank you so much for speaking with me today. And I'm looking forward to seeing what Carbon comes up with next.
Great. Thanks
Thank you so
for
much.
including me. Appreciate
Thanks.
it.